In this video, I'm going to go over the Algebra 2 final exam review. You may want to fast forward through some of these problems if you already understand how to do them. So you only need to listen to the ones that you might need additional explanation on. Let's take a look at number 1. Number 1 through 4 is part of solving systems of equations, which was the first unit you learned in this class. And what you're trying to do is if you were to graph the lines of these two equations, you're trying to find their point of intersection. So what you do is when you look at these two equations, if they're lined up, in other words, the x's are lined up, the y's and the constants, you can add their like terms, and by doing this, you should be able to eliminate one of the variables and solve for the other. But ultimately, your answer will be a point because you're looking for their point of intersection. So let's go ahead and add the like terms vertically. So we have negative 1x plus 1x, which is 0. So our x's will cancel or will be eliminated because they equal 0. When we add our y's, we get negative 1y. And then when we add our constants, 3 plus 1, we get 4. From here, we're going to solve for y. So we'll divide negative 1, and y will equal negative 4, which is half of our answer. To find our other half, now that we know that y is negative 4, we're going to pick one of our original equations. I'll go ahead and pick the first one. Negative x plus y equals 3. Since we now know that y is negative 4, I'm going to replace the y with negative 4, and then I'll be able to find the value of x, which is what's still missing. So I'm going to add the 4 to the right, leaving me with negative x equals 7. Let me move this over here for more room. That would be a negative 1 in front of the x, so I'm going to divide negative 1, and x equals negative 7. So our solution, or our point of intersection, is negative 7, negative 4, which is answer B. Let's look at number 2. For number 2, in order to find the solution for this system of equations, you'll see this is different from number 1 because the variables are not lined up. Now there's a different approach you could take to this problem called the substitution method that would be easier due to the format of these equations. So if you look at the second equation, you'll notice that it says y equals 4x minus 1. This means that y and 4x minus 1 are equal or interchangeable. So what that means is in the first equation, we can replace the y and put the 4x minus 1, which would eliminate the y in the first equation, allowing us to solve for x. So let's copy down our first equation, the 2x, but instead of writing y, we're going to put 4x minus 1, since y is interchangeable with 4x minus 1. And then we'll drop down the equals 11. From here, we will combine like terms and solve the equation. So we have 6x minus 1 equals 11. We will then add 1 to the right, giving us 6x equals 12. Then divide by 6, so we have x equals 2, which is half of our answer. Then, just like the problem 1, I'm going to make a little space here. We're going to choose one of our original equations. The one that solved for y is typically the easier equation to use. Now that we know that x is 2, we no longer need the x, and we can replace it with the 2. And then to find y, we will simply calculate 4 times 2, which is 8, minus 1, which is 7. So our solution to our system of equations is 2, 7, which is answer A. Let's move to number 3. For number 3, it says identify the solution to the system of equations. So in this problem, you don't see the equations, you only see the lines for the equations, and it's very easy. You just look for their point of intersection, which is their solution. And then you identify their x and y value and write their answer as an ordered pair. whoops, I should put x and y. Then if you look at the x-axis, that point, the x value of that point is 3. Then the y value is 2. And so you just look for that answer below, and that would be answer D. Let's look at problem 4. For problem 4, notice the lines do not touch at all. And remember, a solution means their point of intersection. So if they don't ever touch, there's no point of intersection, that simply means there's no solution. Now just to clarify what infinite solutions means, the word infinite means that basically think of it as going on forever. So when we're talking about solutions, it means that there's many, many, many solutions. But if a solution is where two lines touch, for there to be infinite solutions, two lines have to be one on top of the other, which means every point is touching. So for it to be infinite solutions, this is what your lines would have to look like. So no solution means the lines are not touching at all. Let's move to number 5. For number 5, we want to simplify this, x squared y to the 4th power. Now, 4th power means that you're going to multiply something by itself 4 times. So technically, the long way to do this is to write this out 4 times. And then you can add the exponents of the common variables together. So if you add all the x's, 2 plus 2 plus 2 plus 2, you get 8. And if you add all the y's, you would get 4. So this is the answer. I'm sorry, not 4x to the 8th. D, x to the 8th, y to the 4th. The short way to do it would be, since you have the 4 all by itself, you can distribute it. And remember, distribute means to multiply. So in this case, the short way is just to multiply 4 times 2 and 4 times 1, which would also give you x to the 8th, y to the 4th. You just need to understand when you're distributing an exponent that's by itself, you multiply, but when you're combining variables together, the exponents are simply added. So it just depends on how you look at this problem. Let's move to number 6. For number 6, you're multiplying two numbers written in scientific notation. So 4 times 10 to the 3rd times 2 times 10 to the negative 5th. So these are two actual numbers that just have been rewritten in scientific notation that we want to multiply together. So what you do is the part that you actually multiply is the 4 and the 2. So that would be 8 times 10. Now since these are both 10s, in other words, they have the same base, we want to combine them together like we did in the last problem with our x's and our y's by adding their exponents. So 3 plus negative 5 is negative 2. And this answer is answer C. So you want to remember that the part you're actually multiplying is just the 4 and the 2, but the exponents themselves are being added. Let's move to number 7. For number 7, similar to the last problem, even though it's not scientific notation, the process is the same. Because this is a multiplication problem, you're going to actually multiply the coefficients, the large numbers, the 4 and the 3, but the exponents you will do something different to. So you never do the same thing to the coefficients as you do the exponents. Okay? So for the exponents of the x's, make sure that each variable has its own exponent. You want to add the exponents of the x's, so that would be x to the 4th, add the exponents of the y's, y to the 4th, and then add the exponents of the z's, which would be z to the 6th. So if you look down below, that would match answer B. Let's move to number 8. For number 8, the directions say expand, which may be directions you haven't been familiar with in the past. So what you're going to do, expand means, remember, when you're squaring something, it means you're multiplying it by itself. So you cannot distribute in that case because this is a binomial. You can only distribute an exponent if you have a monomial, a single term, inside parentheses. So we're going to write the 2x plus 5 twice, and for this problem we need to FOIL it or multiply it out. Now you can either distribute using the FOIL method, or you can use the box method, which is what I use. Either way, you get the same result. So the 2x plus 5, I'm going to stick on one side, either the top or the side, and the other 2x and 5 on the other. I'm going to put exponents next to the x's here. And when I multiply these first terms, remember, what you do to the large numbers, if you multiply those, you do one level lower to the exponent. So that means you add those. Then I'll multiply the 2x and the 5, and that would give me 10x. Then going to the bottom row, I'm going to multiply the 5 and the 2x, which would give me 10x again. And then the 5x and the 5, I'll multiply those, which gives me 25. Now I look inside the boxes and I have two like terms. I'm going to first copy down the 4x squared because it has the highest exponent. Remember, when you're adding to combined like terms, you add the coefficients, but because you're adding to the exponents, you do one level lower, and there is nothing lower than adding. So in this case, the variable stays the same. And then you put the constant at the end. So you have 4x squared plus 20x plus 25, which would be answer D. Let's look at number 9. In number 9, it says classify the following polynomial. Well, there's a couple things to look at. Hopefully you know the difference between a trinomial and a binomial. If you don't, a binomial has 2 terms and a trinomial has 3. So if I had x squared plus 2, that would be a binomial because it has 2 terms. But if I have x squared plus 2x plus 1, that's a trinomial because I have 3 terms. So hopefully you can see that when you look at this problem, that there are 3 terms. So you can eliminate 2 of them because 2 of them have the word binomial. What students have trouble with is understanding the difference between quadratic and linear. Now, linear would be when you have any kind of polynomial, but the highest exponent you see on the x's, sorry about that, is a 1. So that's linear. Quadratic is when you have a polynomial and its highest exponent you see is a 2. That's quadratic. So whenever you see an x squared, that's quadratic. And whenever the polynomial, its highest term has an x, then that's linear. So because this one has an x squared in it, that would be considered quadratic. Okay, let's look at number. For number 10, it's important you look between the parentheses to determine what to do. You don't want to multiply these, you want to add the like terms. Also, you make sure that you don't just add them in order of how they are in parentheses. Because notice the negative 4x squared should be added to the x squared because those are like terms because they have the same variable with the same exponent. So when you add those together, you're going to get negative 3x squared. From there, you want to add the 6x and the 2x. So 6x plus 2x gives us 8x. And then lastly, you want to add the 4 and the negative 1. I'm sorry, the 2 and the negative 1. And 2 plus negative 1, or 2 minus 1, is a positive 1. And that's all you have to do in that problem is simply understand how to combine the like terms. And again, when you're adding, since it's the coefficients that you're adding, remember the exponents you never do the same thing to that you did to the coefficients. It's always one level lower. And there's no level lower than adding. So the exponents would not change when you're adding, only the coefficients. Okay, let's move on to number 11. Okay, in number 11, we're adding radicals. Not too different from the previous problem in that we can only add radicals that are like terms. Now for radicals to be like terms, they have to have the same number under the radical symbol. So notice that 3 radical 3 and negative radical 3 have the same radical, as well as negative 4 radical 2 and 3 radical 2. Let me go ahead and put 3 radical 3 minus radical 3 together, and then negative 4 radical 2 and 3 radical 2 together. Now in our first set that we're going to subtract or add together, we're going to put a negative 1 there because whenever, just like an x If you have an x and there's no number in front, that means there's a 1. The same with a radical. If there's nothing in front, it means there's a 1. So what we're going to do is we're going to subtract the numbers in front of the radicals. 3 minus 1 is 2. And then just drop down our radical. So the radical part of the problem does not change. And then over to the right, negative 4 plus 3 is negative 1. So I could write negative 1 and then drop down the radical. But just like in front of an x, the 1 is not necessary. So really, the most correct way to write this would be 2 radical 3 minus radical 2, which would be answer C. Number 12, you're solving a radical equation. In order to solve a radical equation, you cannot do anything with the 4x minus 8 with that as long as there's a radical sign surrounding it. So you've got to remember how to get rid of that radical symbol. And the opposite of taking the square root of something is squaring it. So just to recall, you want to square both sides. By squaring the radical, it gets rid of the radical symbol, but does not touch what's under the radical. That remains the same. But you need to remember to change the right side and square that number, so that will become 4. Now you just have a linear equation that you can solve for x. So we're going to add 8, which gives us 4x equals 12. Then we're going to divide 4, so x equals 3. So our answer would be answer C. Now you could check this by simply plugging it back in to our original problem. So where the x is, I'm going to put a 3. And make sure that when you do the math on the left side of the equal sign, it does in fact equal 2. So we have 12 minus 8, or radical 4, and that does equal 2, so it checks out. Let's take a look at number 13. For number 13, it says, which of the following is a factor? Now this might throw you off because you might not have seen a problem where it asks you specifically what is a factor. Okay, so you've got to remember that what the word factoring means. When you're factoring, you have 3 different types of factoring. You can factor out the greatest common factor, which there is none if you look at the 2, the 7, and the negative 30. There's no GCF for this particular problem. You can do double bubble, but in this particular problem, if there's a number larger than 1 in front of x squared, you can't double bubble it. Or you can do bottoms up, which is the type of factoring that's used when the number in front of x squared is larger than 1. So that's the process we're going to use for this particular problem. So let me rewrite our polynomial, and we're going to go through bottoms up to factor this. So remember, bottoms up involves the headphones. So we'll drop down x squared plus 7x, and we'll multiply the numbers in the headphones, 2 and negative 30, and we get negative 60. Now, we want to double bubble the x squared plus 7x minus 60. So we're going to figure out the factors of negative 60 that has a sum of 7. So we've got negative 1 and 60, or the reverse, we could put the negative on the 60. We've got negative 2 and 30, negative 3 and 20, neither of which so far add up to 7, negative 4 and 15, which does not add up to 7, negative 5 and 12, which does. So those multiply to negative 60, but add up to positive 7. Then we're going to draw our iPod cord and drop down our 2. Remember, since 5 cannot be divided by 2, we do bottoms up on the 2, so it's going to move up in front of the x. And this is called a factor. 2x minus 5 is a factor of the original polynomial. Then we have x plus 6 because 12 divided by 2 is 6. So x plus 6 is another factor. So when this question is asking for which one of these is a factor, you're going to see which one of these 4 choices matches one of these 2 factors in our answer. And if you notice, 2x minus 5 is not listed, but x plus 6 is listed. So that's one of the factors of that polynomial. Let's move on to number 14. For number 14, again, we're dealing with factoring. So we want to think GCF, double bubble, and bottoms up. In this particular problem, you're going to have to do 2 out of those 3, because this one does have a GCF. In fact, it has a GCF of the numbers, which is 2, Then remember, to find the GCF of variables, when you're looking at the three x's, it's going to be whichever x has the lowest exponent of the three. So it'd be x squared. So we're going to factor out a 2 and an x squared from each of those terms. Now the GCF will go on the outside. Then when we divide, we're going to get 3x squared plus 5x minus 2. Now you'll notice that that answer is shown as answer B, but that's not factored completely. So I'm going to drop down the 2x squared because what I need to do now is try to see if I can double bubble this new trinomial. So my goal is to have the GCF on the outside and then two binomials on the inside. So I'll drop down x squared plus 5x, multiply the numbers in the headphones, which is -6, and then double bubble that. Now the numbers that multiply to -6 but have a sum of 5 are +6 and -1. So then I'll drop down the 3, and then 6 divided by 3 is 2. And since I cannot divide 1 and 3, I'm going to do bottoms up on the 3, so I'll get 3x minus 1. Then those all drop down into my final answer. Notice the GCF is in the final answer. So if you look at your four choices, you should be able to immediately rule out A and D because the GCF isn't even mentioned. You just have to be careful and factor this completely by using the two different methods of factoring. Let's move. In problem 15, now it says to solve, so it doesn't mention factoring, it says solve, but factoring can be used as a process towards solving. Now what you can do here, however, is look at your types of answers that you have. Because if you have radicals in all of the answers, then there's going to be, you must use the quadratic formula. Factoring will not work. So let's take a look at this using the quadratic formula. So we first need to identify the A, the B, and the C. And the A is 3, the B is the -5, and the C is the 1. Then we'll plug that into the quadratic formula. Okay, so we've got -b, so -5, plus or minus, b squared, so -5 squared, I'm just going to go ahead and write 25, minus 4 times a, which is 3, times c, which is 1, divided by 2 times a, so 2 times 3. So this is the first thing you want to note, is that the -5 becomes a +5, and if you look over to the answers, 2 of them have -5, so you can eliminate A and C, because B and D both have +5s. Now the question is, they all have 6 in the denominator, but what's under the radical? So if you look at it, we've got 25, and then -4 times 3 times 1 is -12. So 25 minus 12 is 13. So you want to choose the answer that has 13 under the radical, which would be answer B. Okay. Number 16 also says solve. Now notice if you look at the answers that you do not have radicals, which means you can use one of the factoring methods to solve this. And because there's a number in front of x squared, you'd need to use bottoms up if you chose to use the factoring method. But if you're more comfortable with the quadratic formula, then use the quadratic formula. So I'm going to go ahead and use the quadratic formula. So we have a is 4, b is -7, and c is -2. So when we plug it in, we have -b, so -7, plus or minus, -7 squared is 49, minus 4 times 4, that's a, times c, which is -2, divided by 2a, so 2 times 4. So then we have, to simplify, the -7, so it's +7, plus or minus, radical. Then we have 8 in our denominator. Now when you do the math, under the radical, we already have 49, but negative 4 times 4 times negative 2 is a positive 32. So we're going to add 32, which gives us 81. Now remember, if you have a perfect square, that's the only time the radical can be removed. So we're going to have 7 plus, square root of 81 is 9. So 7 plus 9 divided by 2 is going to give us one of our answers. And then 7 minus 9 divided by 2 will give us our other answer. So 7 plus 9 is 16, divided by 2 is 8. So 8 is one of our x-intercepts. Oh wait, couldn't read my own writing. There should be an 8 in the denominator. So let me change that real quick. 8 in the denominator. So 7 plus 9 is 16, divided by 8 is 2, so that's one of our x-intercepts. Then 7 minus 9 is negative 2, divided by 8, which simplifies to negative 1/4. So 2 and negative 1/4. Now look very carefully because they look very similar, and the correct answer should be A. Number 6, identify the vertex of the graph of the quadratic equation. So you need to remember, and you need to memorize this formula, although it's very small, for the final. Okay, to find the x value of the vertex, it's negative b over 2a. So just like you do for the quadratic formula, identify the a and the b. You don't have to identify the c in order to find x. So x is going to equal negative, and then b is negative 4 over 2 times a, so 2 times negative 2. This would give us 4 over negative 4, or negative 1. So that's our x value. Let me write that over to the side here. To find y, now that you know what x is, you can plug that back into the original equation for every x. And then when you do the math, the answer you get will be the y value of the vertex. Now remember, when you're simplifying this, you're using the order of operations. So do not multiply the negative 2 and negative 1 first. Do not do that. What you need to do is first do your exponent, because that comes first in the order of operations. So negative 1 times negative 1 is positive 1. And then do your multiplying. So you have negative 2 plus 4 plus 1. And then do your adding and subtracting. So negative 2 plus 4 is 2, plus 1 equals 3. And that would be your y value. So your vertex is going to be negative 1, positive 3. Number 8. For number 18, it says, which equation represents the graph? So there's a couple things you want to remember from what you learned about graphing quadratic equations. Number 1, when the number in front of x squared is positive, then the parabola opens upward. When the number in front of x squared is negative, then the parabola opens downward. So notice this parabola is opened upward, which means it's not going to be C or D. The number that's being added to the x squared, that's the y-intercept. So notice 2 of them are positive 2's and 2 of them are negative 2's. So look and see where the y-intercept is. Notice it's at positive 2 on the y-axis. So because A and B are our 2 remaining answers, we want to choose the one with positive 2. So that would be answer A. What it would look like if the graph was at negative 2 and it was opened up would be this. Notice that's touching the y-axis at negative 2. Okay, number 19. For number 19, we're multiplying 2 radicals. So go ahead and when multiplying, they don't have to be the same, just with adding. So just multiply the numbers, and then you're going to simplify it by doing a factor tree. So we could use 2 and 24, 2 and 12, 2 and 6, and 2 and 3. And then if we write all of those numbers under a radical sign, we have 4 2's and a 3. Underline your pairs and circle your leftover. Take one of each pair to the outside and leave your leftover inside, and then multiply any numbers that you have on the outside. So we have 4 radical 3. So this simplifies to 4 radical 3. Now again, look carefully because C and D look similar, and make sure you choose the answer with the 4 on the outside. and the 3 on the inside. Number 20. Number 20, you're going to add, this is a very simple rational expression problem where you're just adding these fractions. So just like you would add 2/7 plus 3/7, in which as long as they have common denominators, you can add them. You keep the denominator the same, but you add the numerator. Same process up here. Notice the denominators are the same. So just like the fraction I did below, keep the denominator the same, but add the numerators, which would be 6x. Simple as that. Just got to remember that it's the same process as adding regular fractions. Okay. In number 21, it says find the 8th term of the sequence obtained using a sub n equals 2n minus 1. Now, don't worry about the a sub n. What you're using is the 2n minus 1. So the n means what term are you looking for? So whatever your term that the problem is asking you to find, you're going to plug in that number for the n. So you're going to plug in the 8. This is the n, because remember, the n is the term you're looking for. And then you just do the math. It's very simple. 2 times 8 is 16. And 16 minus 1 is 15. So 15 is the 8th term in a sequence that we don't know what the sequence is because we haven't found it, but you can find all of the numbers in the sequence by plugging in the 1 for the first term. So you can plug in 1 for n, then 2 for n, then 3 for n, and you would find you would have a sequence of numbers. Okay, number 22. These last 3 problems are problems that are review from first semester. So it's basically to make sure that you're still carrying over the knowledge from the important things that you learned in the first semester. So if you look at this, we're solving this, it's just a linear equation. There's no x squared in it. It's just a regular equation. So remember when you see the parentheses to distribute, that means multiply. So you would have 18x plus 6. Then you'll drop down the minus 30. So that's the left side. Then you'd have 6x minus 12 on the right side. And now you would combine like terms. Start with ones that are on the same side of the equal sign. So 6 minus 30 is negative 24. Now, remember to get your like terms together if they're on opposite sides of the equal sign. When you move one over, change its sign. So move your letters left. So that gives you 18 minus 6 is 12x. I still have the minus 24, and now I have equals negative 12. And then move your constants to the right. So we'll add the 24 to the right. That gives me 12x equals 12. And then just divide by 12 and you have your answer. So x equals 1. Number 23. Number 23 says which equation is represented by the given line? Well, just like the previous parabola that we looked at, the y-intercept, in this case, which is 3, is the number being added to or subtracted from the variable. So they all have plus 3, so it's really going to depend upon the slope. So if you look at all the slopes, 2 of the slopes are negative and 2 are positive. So notice this line is going upward, which means the slope is positive. So we can eliminate C and D. So now if we do our little slope triangle, remember, if it's got a slope of 1/3, it means it's got a rise of 1 and a run of 3. So if we go up 1 from our y-intercept and to the right 3, if we still land on the line, then that should be our slope. For choice B, the slope is 3 or 3 over 1. If you were to go up 3 and right 1 from the y-intercept, look on the graph, up 3 and right 1, notice we didn't land on our line. So for this one, the slope is definitely 1/3. The smaller the slope, the flatter the line. Okay, and then the last one, number 24. Number 24 says to evaluate the function. So evaluate means you take whatever this tells you, whatever number's in parentheses, is the x. Now you don't plug it in here. Where you plug it in is here and here. Okay, so it's just telling you this information right here is just telling you that the x is 6, So you're going to replace the x with 6. Now the biggest mistake made in this problem is with this negative sign, because people want to attach that negative sign to the 6 that they plug in. But you only square what you plug in. So what I do is I immediately change that negative to a 1, so it's its own number, and then I replace the x only with what you're plugging in for x. Then also in the middle, that x is replaced with 6. And then just like one of the problems we did earlier in this particular review, follow the order of operations. So do not multiply the -1 and 6 first. Square the 6 first and drop down the -1. So you would have -1 times 36, because 6 squared is 36. So ultimately, that's going to be a -36. Then we'll drop down the rest. 3 times 6 is 18. And now we just add all the numbers together. So -36 plus 18 is -18. Minus 8 is -26, which would be answer A. So that completes the review for the Algebra 2 final exam. Good luck on your final exam, and please feel free to email me with any further questions that you have.